Welcome back to our online lecture series on textile effluent treatments. So in the previous video we saw about trickling filtration process and some intro about the secondary treatment method. So in this video we'll be seeing about the activated sludge process. So the most common suspended growth process used for municipal and industrial wastewater treatment is activated sludge process. So it involves wastewater aeration in the presence of a microbial suspension and solid liquid separation following the aeration, then discharge of clarified effluent, then wasting of the excess biomass, and the return of remaining biomass to the aeration tank. So the wastewater containing organic matter is first aerated in a aeration basin, and this aeration basin contains microorganisms. So these microorganisms metabolize the suspended and soluble organic matter present in the wastewater effluent. So the part of the organic matter is synthesized into, it is consumed by the bacteria or any other organic agents. So they consume the biological matter and they synthesize their own metabolism process and they convert it into new cells, that is they multiply, and they oxidize the part of the organic matter into carbon dioxide and water, as they can derive energy in this process. In activated sludge system, the new cells formed in the reaction are removed from the liquid stream in the form of a flocculent sludge in settling tank. So this settled mass is then, a part of this is then returned into the aeration tank, and the remaining is taken as waste sludge. So here you can see a typical diagram of the activated sludge tank. Here aeration is carried out and sludge is obtained through the bottom. A part of this sludge is then again circulated back into the tank so as to facilitate the biological process. So here you can see the flow sheet of the activated sludge process. So initially in the primary treatment process, we know that first we do screening, then we go for grit chamber, right, grit removal, and then we go for primary clarifier. Okay, so from primary clarifier, sludge formed is removed and it is digested and then it is treated, it is disposed of. Then we go for secondary treatment. In secondary treatment, in this case we adopt activated sludge process. So after the primary settling tank, there will be activated sludge tank. So we'll having an activated sludge tank, and after that there will be a final settling tank. From the final settling tank, the sludge is removed. So the sludge removed is taken off, and the excess sludge is taken to the digester, while some amount of sludge is returned back to the primary settling tank. Then it comes through the activated sludge tank again, and there it undergo further processing. This increases efficiency of the process. So the return activated sludge increases bacterial feed, and also it also increases the efficiency. So the operating units present in an activated sludge process are, so preliminary treatment is required. So primary treatment processing up to primary sedimentation tank, we need screening, grit removal, and primary sedimentation, and then it is followed by then it is followed by the aeration tank for activated sludge process. Then after this we have secondary sedimentation tank, and which is followed by sludge thickener and sludge digestion tank. So in primary treatment, we remove the grit as we saw in the flow diagram. So first screening is done and then removal of grit is done. So larger solids are removed by screening, and then smaller solids are somewhat removed by the grit chamber. And then after that, the suspended impurities are removed by the sedimentation tank. So the particles having specific gravity larger than 2.65 is removed easily under gravity, so it is removed in sedimentation process. So by removing this settlable solids, it prevents deposition in aeration devices. So aeration device is sensitive, right? So we can't allow any deposition there. So in order to remove that, in order to prevent the deposits from depositing there, we are doing this pre-treatment processes. So the detention time for primary sedimentation tank should be kept shorter, so that the effluent will be fresh. So fresh effluent will be treated better in biological treatment. So the detention time of primary sedimentation tank is kept shorter, okay, and then it is taken for aeration. So in aeration process, the effluent from the primary treatment tank is fed into the aeration tank, and here we are mixing with the previously activated sludge, that is the return activated sludges mixed with this fresh effluent. So the aeration tanks are rectangular in shape, and they have a depth of about 3 to 4.5 meter, and they also have a length in the range of 20 to 200 meter. So they have a width 3 to 4.5 and depth is 4 to 6 meters, and their length ranges from 20 to 200 meters, and the detention time is mostly 4 to 8 hours. So air is continuously introduced into these tanks in order to facilitate aerobic reaction. Okay, so we use aerobic process, and the aeration tank is continuously stirred to introduce the mixing of the effluent properly with the aeration. So aeration is provided regularly. The aeration is done by three methods. One is air diffusion mechanism, another one is mechanical aeration, another one is combined aeration. So in air diffusion method, we pass a compressed air with under a pressure of about 35 to 75 kilonewton per meter square. So we are introducing this compressed air under pressure into the aeration chamber. This passes through diffusion plates or diffusers. In mechanical aeration, the effluent is stirred by means of mechanical devices like paddle. We use paddle to stir up this this sewage or effluent from textile industry, so as to introduce the atmospheric air, and by continuously changing the surface of effluent. So we are circulating from bottom to top, and we are mixing it so as it facilitates the mixing with atmospheric air. In combined aeration, we use both air diffusion and mechanical aeration in a single unit. So after this aeration with detention about 8 hours, then we go for secondary sedimentation. The effluent from this is taken into secondary sedimentation tank, and here it is similar to the primary sedimentation tank, except here we don't provide any provisions for skimming because oils are removed already. So here only suspended particles are present, hence we won't provide any provision for skimming. So here the tanks considerable length of overflow vias are desirable to control the velocity, because here the particles are lighter, right? The particles obtained are lighter, and its setting is hindered by the current. So in order to obstruct the current flow, we introduce some overflow vias in the length of the sedimentation tank. After this, the sludge formed is taken to sludge thickener, and which is then digested there. The sludge from primary and secondary tanks are both taken to the digester. So the sludge contains about 90 to 99% only moisture is there. Only 1% is of biological compounds, and remaining 99% is purely water. So we need to remove the moisture so as to reduce the treatment components volume or its capacity. In order to reduce that, we need to thicken it first. So we need to remove the moisture in the sludge. So first we introduce it into a sludge thickener. So here the water is evaporated and we get thickened sludge, and this thickened sludge is then taken into digestion tank for further reduction. So here you can see the flow process of a conventional activated sludge plant. So a particular inflow and BOD is fed into the aeration tank, which is also called a reactor. So this may be a batch reactor or a continuously stirred tank reactor, but here it is CSTR, that is continuously stirred tank reactor, because we mix it continuously. So this here you have a double ellipse, right? It shows stirring. So here the process may be continuous or batch process, but the stirring is done frequently. and the volume is represented by V, and the concentration of the mixed liquid suspended solids is represented by XT, and BOD is Y in the aeration tank. Then this water is this effluent is taken to the secondary clarifier, there where we form the waste sludge, and there some amount is returned back into the aeration tank. Okay, so this is the process of activated sludge treatment. Then in order to design a plant, we need to keep in mind the following consideration. So first one is aeration period or hydraulic retention time. Second one is volumetric BOD loading. Next one, food to microorganism ratio, and then is sludge age of the sludge. So aeration period decides the loading rate at which the effluent is applied to the aeration tank. So the rate of application of effluent to the aeration tank is called this aeration period, and it is also called as detention period or hydraulic retention time. So it is the ratio of volume of tank to the rate of sewage flow in the tank, that is V by Q, gives you the retention period. Next is volumetric BOD loading. It is the BOD, fifth day BOD applied per volume of the aeration tank. So representation of BOD 5 per volume of aeration tank gives you the volumetric loading. This volumetric BOD loading is also called organic loading. So organic loading is the ratio of mass of BOD applied per day to the aeration tank through the influent sewage in grams per volume of aeration tank in meter cube. Okay, then next is food to microorganism ratio. Here it is an important parameter. So it is expressing BOD loading in respect to the microbial mass in the system. So food is the amount of BOD present, and microbial ratio is the total quantity of microbial mass present. So food load applied is represented in kilogram or gram, and it is represented by the letter F. So total microbial suspended solids and mixed liquid of aeration tank is represented by letter M. So F by M is equal to daily BOD load applied to the aerator system in grams divided by the total microbial mass in the system. That is, F by M ratio can be written as Q into Y naught, which is Q is the flow rate and Y naught is the BOD, and divided by V into XT. V is the volume of the tank and XT is the MLSS in MLSS, right? Mixed liquid suspended solids. The total quantity of the concentration of the this mixed liquid suspended solids gives you XT. So MLSS in milligram per liter. So this gives you the food to microorganism ratio. Next is sludge age. So it is defined as the average time for which particles or suspended solids remain under the aeration. So it represents the residence time of the biological solids in the system. So it is different from the aeration time, that is liquid. It is different from the liquid retention time at it, as it is maybe less than 3 to 30 hours. So residence time of biological solid is much greater, and it is expected in days. So this sludge age is represented in days, while liquid retention time is represented in hours. So when sewage passes through the aeration tank, the resultant biological growth and extracted waste organics are repeatedly recycled from secondary clarifier back into the aeration tank, and it increases the retention time of the solid. So this time is called, this additional time is called solid retention time, SRT, or mean cell residence time, or we can say sludge age. So you can keep in mind sludge age or solid retention time. It is denoted by the letter theta C. So it is the ratio of mass of suspended solid in system by mass of solids leaving the system per day. So sludge age theta C can be represented by V into XT by QWXR plus Q minus QW into XR. So XT is concentration of the solid, that is food available. V is the volume of aerator. QW is the volume of waste sludge which is allowed per day, and Q is the sewage inflow per day, and XR is the concentration of solid in RAS, that is return activated sludge, and XE is the concentration of solids in effluent. This is also represented in milligram per liter. So these are the design consideration while we are going to design a activated sludge treatment plant. Okay, so far we saw about the Activated sludge process, what are the treatment units present in the activated sludge process, and then we saw about the various design consideration in this video. So in the next video we'll be seeing about the next method of secondary treatment, so which is secondary sedimentation, right? We'll see about that in detail in the next video, and thank you for